Welcome back. This lesson is called Relating Polynomial Functions and Equations. The Getting Started piece here asks us, match each quadratic equation to a graph below. What characteristics did you use? Well, in grade 11 we learned quite a bit about quadratic equations. When they're listed in this type of form, I write it out here, x minus p all squared plus q. And then there's a lot of neat things that we know here. That we know that the vertex, oh boy, it's like kindergarten writing here. Vertex is at PQ, P comma Q. And whether or not A is positive or negative tells us whether it's opening upwards or downwards. So the first one I look at is, here if I kind of number them, 1 and call this one number 2, it looks to me like number 2 is already in that form. So the vertex for that one would be at 1, 7, 1, 7. So that would be the vertex. Sounds good. And in this case here, A is negative and it opens downwards. So it seems to me like this one would be a number 2. So that one's done. Looking at the other ones, none of the other three seem to be in this A x minus p all squared plus q form, which makes it easy to graph. So some of the other things that we can take a look at is that A value. If A is positive, then it opens up. Maybe we'll just make a graph here instead of writing it out. If A is less than 0, it opens downwards. Now, we don't actually have this in the entire form, but it's pretty easy to see that it's the same thing as the coefficient in front of the leading coefficient. So in this case, it's negative. So here we have A is less than 0. So number 3 is going to be looking kind of like this. Number 1 is a positive 1, is the leading coefficient in front of that x squared. So it's going to be looking like this. This one here, if we were to multiply it out, we have a positive 2, a positive x, and a positive x. So again, my A would be positive, so it would be opening upwards. So it would look kind of like that. So since, pardon me, since we already have number 2 finished, looks like we've got 2 other ones that open upward, one that opens downward, and so clearly this here must be number 3. So we've got those two kind of figured out. So we've got number 1 and number 4 yet for us to figure out. So some other characteristics. So I guess the one big tool that we talked about was when it's in this form. Maybe I should use the letter A here. So one was A. If we have this in this form, the vertex is a PQ. The one is looking at the A value or the leading coefficient. In this case, it's going to be the same thing. The C, another good way to take a look at it, are the intercepts. So there are two intercepts we can look at, the y-intercept and the x-intercept. The y-intercept is simply going to be the constant. If it's in this form, it's whatever the q value is, or if it's written in a more standard form, then it would be 4. Oh, here it would be 4 as well. And here, if I've multiplied it out and tried to figure out what the constant would be 2 times 1 times 2, so it would be 4. So in fact, when I take a look at the graphs, check it out, they are all cross the y-axis at 4. So that doesn't really help me. Okay, so in this case, they are all the y-intercepts at x value of 0 and y at 4. Well, what if I just go in the other direction if I check out the x-intercepts? So how to figure out the x-intercept? To figure out an x-intercept, and what's one that we haven't done yet? We figured out number 2, number 3. Let's take number 4 because it's in a nice pattern here and it's all set up for us. The x-intercept is going to be when the y value is 0. So if I go like this, 2 times x plus 1 times x plus 2, and if I say, oh, well, the x-intercept is when the y value is 0, I'll put in a 0 for y, and I think, okay, so when will this be equal to 0? 2 times, and it's nice because it's in factored form. The answer would be whenever this factor is 0, So whenever this is 0, that would give me an x of -1, would cause this to be 0, or when x is equal to -2. So I have two x-intercepts, one when x is -1, so x is -1 and then y is 0. And my second one to look for is when x is -2 and y is 0. So this y equals 2 times x plus 1 times x plus 2 will be whichever graph has those intercepts at -1 and -2. Oh, and here it is. Here's -1 and -2. So that one would be number 4. Process of elimination. This one must be number 1. Okay, I'm going to see if I can pause this thing now. Where's my recorder? No.